All right, welcome to today's KCS talk, and this is also the last talk for this semester. We have two speakers. The first speaker is Joshna Kurra. She's a member of Dr. Jim Griffin's research team. Okay, she will give a 30-minute talk, but we hope we can use the last 5 minutes for Q&A, and then we have another speaker. Okay, so this is our speaker, Joshna Kurra. The topic is using AI to create specialized code generation tools. Okay, so let's welcome our first speaker.
Thank you. As Dr. Cheng mentioned, I'm Joshna. I'm a master's student here at UK studying data science. This is the first semester of my master's degree, but I've been at UK for about 3.5 years now. I was studying computer science for my bachelor's degree, and I've been a part of the UK Fabric team for a little less than 1.5 years now. When I began, I was helping out with the teaching materials or the educational resources that Fabric offers. And later, I started working alongside Mami Hashida on a generative AI project, and that project is what I'm going to be talking about today. Today, I'll start off by giving you a brief introduction to Fabric. Then I will talk about the motivation behind starting this project, followed by a high-level overview of how our solution works and what it is. After clarifying what LLMs and RAG, both integral parts of our solution, are, I'll move on to talk about our approach, the different things we've tried, such as models, tools, embeddings, and so on. Finally, I will demonstrate some of the results that we have so far and conclude and have some time for Q&A. Fabric is an international infrastructure that allows researchers to conduct experiments in an environment that closely emulates the real systems that drive distributed applications today. Its primary capability is to provide users with deep in-network programmability with sites that are connected with dedicated optical links. There are 35 Fabric sites in total, including 4 international sites, and each of these are able to integrate with facilities and networks that researchers and scientists already use, such as HPC centers, campus labs, cloud testbeds, and the internet. Each of the sites or routers offer traditional compute and storage, but also advanced resources such as GPUs, FPGAs, and programmable NICs. To give you some real-world examples of what Fabric has been used for before, I'll just go over some interesting projects that we've seen. An excellent example is this El Niño forecasting project between University of Miami and CP Tech, the Center for Weather Forecast and Climate Studies in Brazil. They used Fabric nodes to create a topology that makes the sharing of data that they use to predict the El Niño conditions much faster. You can see from the graphs here that once they started using Fabric, the throughput became faster and also the runtime of their applications becomes faster. Another notable project is Flynet. The aim of this project is to use edge-to-cloud computing to make the processing of images that are captured by drones in fire-prone areas much faster. Here, Fabric acts as the cloud, and it is especially useful because it allows you to program the network so that you can predict and test certain real-life network conditions before you actually deploy the application. And here are several more areas that Fabric has been used by researchers for, including edge computing, in-network caching, and smart data distribution. Before we get into the talk, the actual details of it, I just want to give you some details or terminology about Fabric to help you understand everything better. In Fabric, to run an experiment, you first have to create a slice. It is kind of a logical collection of resources, and within these slices, you can reserve nodes, which are the actual virtual machines that you run your experiments on. So here is an example topology. This whole thing would be considered one slice, and each of the nodes in here are the virtual machines that you can connect using network services and run your experiments on. And this is sort of a hello world equivalent of how to run an experiment on the Fabric testbed. You can you can write your program or code in a Jupyter notebook, which is then run on a Jupyter Hub server. For anybody who might not know what Jupyter notebooks are, they're sort of a web-based interactive environment where you can write Python code. And you can note here that the first thing that they do is, there you go, is import the Fabric testbed extensions and FabLab Manager. That's generally the first line of code or first piece of things that is done in any Fabric notebook. And then you move on to reserve the resources that you need and run your experiment. We think Fabric is a great asset for experimentation in various fields, but we acknowledge that there are some challenges in using Fabric. When you are a new user on Fabric with no previous exposure to it, there is quite a steep learning curve. You're forced to familiarize yourself with the FabLab API before you're able to do any of your experiments because it is necessary to program on the testbed, even for basic things like reserving and managing your resources. Yes, we have several example notebooks, Jupyter example notebooks, and also hundreds of forum posts that you can browse with previous users' questions. But there are so many of these resources that it can become quite overwhelming and difficult to find what you're looking for. And in such a case as this, when you don't know how to write the code needed, there is a very popular solution these days, ChatGPT, or more generally, code generation tools. But the problem with using such generalized tools is that, one, they're not trained specifically for coding questions, and two, they're not likely to know enough about Fabric to give you an accurate and relevant result. So our solution is to create a specialized code generation tool for Fabric users that is more knowledgeable about Fabric and is especially trained for coding questions. We hope that this will make onboarding easier for new users and also allow them to primarily focus on their experiments rather than trying to learn and understand the FabLab API. LLMs and RAG are the basis of our solution. Large language models are very large deep learning models that are generally used to recognize and generate human-readable text. Retrieval augmented generation, or RAG, allows these models to reference an external knowledge base and take information from that knowledge base to augment with their inherent ability to produce a more relevant and accurate result for the user query. These also help, as you can maybe gather, they can help minimize hallucinations, and they're also a little bit less resource intensive, actually maybe a lot less resource intensive than fine-tuning your models for your specific use case. The knowledge base in RAG that I mentioned is usually a vector store that stores anything you want your model to be especially knowledgeable about. There are three main steps in creating this: loading, splitting, and embedding. When creating the vector store for Fabric, we tried loading in several things. We tried loading in our example notebooks, we tried loading our teaching material notebooks, and also a combination of these. More recently, we realized that a lot of our examples had outdated information from previous releases, so we tried cleaning that up, and this has definitely given us better results after we cleaned up our input data. The next step is splitting, and when it comes to this, there are several options. One of the things that we tried was splitting by markdown. What that means is every time you see a markdown cell in a Jupyter notebook, until you see the next markdown, all of that is considered one chunk and passed in as one chunk. Another thing that we tried is splitting by notebook, which means we pass in a whole notebook as one chunk by itself. And the advantage of this is that it preserves the context of the notebook. This has actually been the splitting technique that has worked the best for us, and that's what we currently use. Finally, the split notebooks or documents are embedded into the vector store. And in this process, we tried several large language models that are available out there. One of the first models that we tried was Code Llama. Initially, we weren't really getting the best results with it. It would do very well with simple queries, but anything more complex, it wasn't able to perform well, or it wasn't able to do it consistently. And this is what made us pivot and try out OpenAI's GPT Mini 4. Because this is kind of considered as an industry standard in some sense. And as expected, it did give us pretty good results, but we were really trying to stick with open source models. So that's why we tried a lot of the other models that are listed on this slide here, like Mistral, CodeStral, CodeGemma, and DeepSeek. A lot of these models, when we tried them initially, were not performing very well. But over time, especially in the past couple of months, they have improved significantly up to the point where they're doing as well as ChatGPT or OpenAI's GPT Mini 4, or even better than that. So we, as you can maybe tell, the open source models, everything here is open source except OpenAI's GPT Mini 4. That one, you have to make an API call to use it and also pay per query. It's not a huge amount of money that you're having to pay, but at the same time, it's always better if you're not having to pay anything. And one other thing that we really focused on during this process was prompt engineering techniques. Prompt engineering is an attempt to guide your application to output the results that you want it to output. You can do this by phrasing your questions a certain way, or by giving your application some background information. One of the ways that you can do this is by defining a system prompt. For example, it's like a set of instructions or background information that you want your application to follow for all the user queries. For example, we defined a system prompt that tells our application or model to always use FabLib Manager or to always generate Python code. And the other side of prompt engineering is simply trial and error. For example, over time, we've realized that including the phrase using FabLib Manager explicitly in the user query makes the model perform better. So now we ensure to append this phrase to every user query before it's passed in to the model. Finally, we also tried tuning several parameters of these large language models. One of the first things that we experimented with was the temperature. The temperature is like a dial that you can turn up and down to adjust the model's creativity. A higher temperature makes the model more creative, whereas a lower temperature makes it more predictable. For Fabric, we've noticed that mid to low temperatures work well because we want the model to take the retrieved information and kind of customize it per the user query, but not entirely alter it. And more recently, we've been using a temperature of 0 for all of our tests because this gives us somewhat stable results from one run to another. And another thing that we've kind of explored is the context window of these models. Models with larger context windows are usually able to take in and digest a lot more information than models with lower context window. It's a sort of, it kind of helps define how much information your model is able to process. But models with smaller context windows, even though there's a trade-off with the how much information it's able to process, it's actually able to run faster. So there is a trade-off with those. We haven't necessarily figured out which models work the best for us. Sometimes a model with a larger context window is doing well, but it's just way too slow. And sometimes models with smaller context windows perform just as well, and they're fast too. And the final thing that we've tried is experimenting with how many documents we're retrieving from the knowledge base. This is called the top K. This is kind of tied in with the context window because you can imagine that a model with a smaller context window won't do so well with a lot of documents being retrieved from the knowledge base. But regardless of the context window, we found that having a lot of documents being retrieved kind of confuses the model. So it's good to experiment for your specific use case and try to find or figure out what is a good medium. For Fabric, that has been about 2 documents per query. Before I move on to show you some of our results, here are the specific tools that we used in building this. LangChain is an open source framework that is used to build LLM applications. It's kind of a one-stop shop for building all of this. And Chroma is the application database that we used. It's a specialized database for LLM applications. And Ollama is the tool that allows us to pull open source models and run them locally on our machines or servers. Before I walk you guys through the results, here's just a quick reminder of the terminology that we discussed. I think it will be helpful to keep these in mind as we go through the results. And before I explain each of these slides to you, just some things that will help you understand them better. On the right-hand side, my right hand, but your left hand, there's the model that I used for this specific slide, and also if I included RAG or if I ran the query without including it. And on the other side, you'll see the exact query that I ran. And the image itself is the generated code, and anything that's circled in black is code that was incorrect. So incorrect code generated by that specific model. And I also displayed results from 3 different queries here, an easy query, medium, and hard difficulty level, just to kind of let you see different difficulty levels. So the first query here is an easy one. How can I check what slices I have? So you can create several slices on the testbed if you'd like, and if you want a list of all of them, this is kind of what you would want to, well, not this, but that's what I was asking the model to do. And when I ran it without RAG, you can see here that this and this, both of these parts are wrong. First of all, the import statement is wrong. That's not how you import FabLib Manager. And this get all slices function that the model generated here, that does not exist on Fabric. That's completely hallucinated. So if you run this code on the testbed, you will get errors. But for the same query, same model, when I include RAG, you can see here that everything is correctly generated. The import statement is fully right, and also the list slices function is what is used in Fabric to get a list of all your slices. It also gives me some bonus information of alternate ways that I can look for a very specific slice if I want to. And this is a medium difficulty level query where I ask, how can I look up when my slices expire and extend them by 20 days? On Fabric, your slices do have an expiration date, but you're allowed to access them and extend that expiration date. And you can see here that the whole thing is circled in black because everything it generated is completely wrong. The import statements, as you've seen before, these are not the correct import statements. And this authenticate function, this get all slices function, and the extend slice function are all completely hallucinated. Those do not exist with the FabLib API. So you can see that this is completely wrong. It wasn't able to do it right. But when I use the same query, include RAG with the same model, you can see that most of the information here is correct. The import statement is good. The get slice function, that does exist, it works. And the get lease end function also exists, and that's how you figure out when your slice expires. And the renew function that is kind of covered here also exists on Fabric, and that's how you extend your slice. The thing that's wrong, circled in black here, it isn't that the line itself is wrong, it's that the code uses a date time module that it did not import. It's supposed to import that from Python, but it didn't import that. But everything else, all the Fabric stuff especially, is correct. Finally, this is a hard query. How can I create a slice with 2 nodes connected with L3 network using basic NICs and do CPU pinning and NUMA tuning and launch iperf tests between them? You can see that it's quite complicated because it has a lot of different parts that we're asking the model to do. And when I run it without RAG, you can see that there are several parts of code that are incorrect. The import statement is once again wrong. And when it tries to create the L3 network here, it uses a connect nodes function that does not exist on Fabric, and neither do the set CPU pinning or set NUMA policy functions. None of those exist on Fabric. Those are hallucinated. But when I run that same query with RAG, you can see that everything here is correct. This is almost an exact replica of what our example notebooks ask you to do if you want to do this task. So you can see that the import statements are correct. It sets up the L3 network correctly. And then it does the NUMA tuning, it reconfigures, and then runs iperf tests. So even with a query as difficult as this, which asks for several different parts, the model is able to do quite well if we include RAG, if we give it some supplemental information regarding Fabric. I hope this demonstrates to you exactly how useful RAG can be if you have a sort of niche application or project that not a lot of people use, that doesn't have a lot of resources out there on the web that models can be trained with. You can use this to make those models better and make it especially useful for your users. I think if I have some time, we do have an interface here, so if you have any questions, I know that you guys might not know enough about Fabric, so you don't have to ask Fabric questions, but if you want to just for fun ask any question regarding coding, I can type it in. Okay. Let's see. We'll do it without RAG because this doesn't necessarily have to do with Fabric. And I'll just ask, write a program that prints all even numbers between 1 and 100. Let's see. Maybe? So yeah. Maybe I can make it bigger. It shouldn't be importing FabLab here because it doesn't have anything to do with it, but I guess it's kind of corrupted the model. We've kind of corrected the model with all our Fabric information.
The bottom part is the response of the library?
Yeah, the response from the model, yes. Yes. Yeah, so I don't know if you guys heard that, but as Mami pointed out, this is because even though this doesn't include RAG in our system prompt that I explained to you earlier when I was talking about prompt engineering, we include that you should use Pablo Manager and generate Python code. But yeah, I just wanted to demonstrate that. And like I said, if it seems applicable for your domain or project, please try to make your own code generation tool using RAG. It is not a very difficult task, and I think that if you set your mind to it, you can do it. And to conclude, we have 3 takeaways so far. As you can see, RAG definitely improves the accuracy and relevancy of your results. And secondly, what you store in your vector store is extremely important. Keeping that data clean and up to date will make your results better. And finally, just like with any other LLM applications, it's hard to ensure stability between one run to another. So that kind of uncertainty will be there, but we're excited to work more on it and see how far we can go. Thank you.
All right. Make sure it's on.
I think it's on, yeah. So we had to use a RAG model for our capstone project, and I was wondering what types of documents that you had to put into the RAG model in order to get the results that you showed on the.
So the results that we showed on the screen, the vector store that was used for this had Jupyter example notebooks. So these are Jupyter notebooks that have some comments, some markdown cells, and some code of how to run certain things on Fabric, like how do I list the slices on Fabric? How do I delete a slice on Fabric? And there's also a section called complex recipes. Those are also Jupyter notebooks that just kind of demonstrate how do you do some of the complex tasks in Fabric. And we took all of those example notebooks and passed them into the vector store.
So we still have a few minutes before, the second speaker, we'll give.